Alright class, today we're going to talk about one-sided limits. I already have some stuff written down for you, but you should be writing this down. The first thing that's important is it's the same notation as it was before with limits. The only difference are these two signs here, okay? And by the way, you should have f of x equals and then f of x equals technically. Okay, so here's what this means. When you see the number with a little plus sign next to it up into, it's like almost raised to the plus sign if you want to say, that means that you're coming along the path from the right. That's the key, from the right. And if you see a little negative sign after the number, that means you're coming from the left. Okay, and we're going to show you that down below. The next thing that's important is if a function is continuous, it has to have a couple things. Now I know this seems like a lot because at the end of the day, you just have to see, is there a break in the graph or not? That's basically what continuity means. Is the graph continuous? Is there a break in the graph or not? Okay, if there's no break in the graph, it's continuous. So, by definition, what it means is that there's a limit, that there's actually a value at that value, and then those values match up. So here's an example of something that's not continuous. You guys should agree with me that this thing has a limit. As x is approaching 4, the value of the limit is 2. However, the actual value of the graph when you're at an x of 4 is 3. So since those don't equal, it's not continuous. And again, it's clearly easy to see that because if you're drawing along this line, right? If I'm drawing along this line, there's a break in the graph. It's broken. So that means it is not continuous anymore. Okay? It's only continuous if it's a continuous smooth line. Alright, so you could pause this if you need to write all this stuff down. Otherwise, I'm going to move on. So pause the screen if you need to keep writing. Alright, so now let's look at how this works. Use the graph to answer the following questions. So here's my graph, and let's answer some questions. What is the domain of f and what is the range of f? You know what, we're going to skip those for today because honestly, that's not the part that I care about with you guys here. Let's go all the way down. No, you know what, let's start with 3. This is basically this is kind of a good review. What is the y value when x is negative 3? So I go to an x of negative 3, 1, 2, 3, and I find the y value. Well, this is where it's split. So if you look, that's not a filled in circle, so we can't count that one. So it's actually this one right here, which is a 3. So this is equal to 3. And f of 6, if you go to an x of 6, you go down to this point, that's a negative 2. So those are just telling me what are the points at that x value. Okay? Now we're going to start the new lesson today. I want to find the limit as you approach 3 from the right. So where's 3 at? Well, here's an x of 3. Okay? From the right of 3, I jump onto the curve. I'm just picking a random spot on the curve, and I'm starting to approach that value. Well, as you can see, this is an asymptote. So at an asymptote, notice how it's going to just keep going down forever from the right. So we would actually say that this is approaching a y value of negative infinity. You can do that when you have these left or right limits. Okay? Now let's look at the next one. It says, what is the limit at x equals 1? Okay, so again, this is a problem from yesterday. You just have to see there's no left or right, which means you have to check both of them. Well, here's x equals 1 right here. So if I'm approaching from the right and from the left, you end up at a y value, no matter which way you approach, of 4. Okay? Alright, let's see the next one. Does the limit at x equals negative 3 exist? And if it does, what is it? Well, let's find x equals negative 3, 1, 2, 3. Right away, you guys should be able to see that there's a break right at negative 3. Whenever you have a break, there is no limit. So, no, the limit does not exist. Because if you come from the right, you're going to end up here, and if you come from the left, you're going to end up here. Those are not the same values. Is f continuous at an x of 5? Well, let's find where x of 5 is. That's this line right here. Let's find the spot on the graph. It's that point. It's a nice solid point. Sure enough, I can draw through it without hitting either an open hole or a gap. So that is continuous, yes. There's no break in the graph there. Give the coordinates of one of the x-intercepts. We don't really have to worry too much about that, but if you wanted to, you could have told me that that x-intercept of 4, 0 is an x-intercept, wherever the graph hits the x line. Okay, so that's just everything kind of, looking at those. We're going to look at it a little bit more on the next page. Some important parts about this, again, though, is number 4, from the right, and then number 7, continuous. Numbers 5 and 6 were reviewed from yesterday. All right, let's keep going. Oh, I did not erase all these lines. Maybe I should do that. So the next thing is, okay, I did erase the problem. Good. Given the function, find the following. So again, to read this is saying we're approaching -4, but we're only approaching it from the left. So I don't want this side down here because this is from the right. I have to find the point and then the stuff that's to the left of it. So that would be this branch up here. So normally, if this just said what's the limit as you approach -4, you guys would say it doesn't exist because there's two different answers here, right? There's this one down here and this one up here. But since I'm only asking it from one side, we're going to just be able to tell me, well, from this left side, we're approaching a y value of 3. So that can exist if it's a one-sided limit. Now I'm asking the same question, but from the right. So again, I'm approaching this x equals -4, but I have to go on the line or on the graph from the right. So I find the line that's to the right of this x value. It would be this line right here. And as I approach from the right, the y value that I'm approaching is -2. Right away I'm going to look, let me see if there's a, no there's not. Okay, I was going to say, what that means is, since both of those are different at -4, that means the limit itself does not exist, but I didn't ask you that question, so. Alright, let's do another value. Now we're asking about x equals 1 from the left. So let's find that. So here's x equals 1. From the left would be this way. So as I approach from the left, the y value I'm hitting is 3. Okay. Okay, that's the only one I have for that one. Now let's do x equals 2. Alright, let's pick a different color. Let's do orange again. Okay. So this is 2 from the right and 2 from the left. I'm going to do both of those together. Okay. So let's look at our graph. So here's x equals 2. From the left of this graph, we're on this line right here. So I'm drawing the line towards the x of 2, and we hit this y value of -1. So from the left, which would actually be number 5, we are going to put -1. Because again, I'm coming from the left branch. Basically, just look at the branch to the left of where x is 2, and then look at the branch where it's to the right, which would be this up here branch. We're to the right of 2, and as it's coming towards the 2, you're going to hit a y value of 5. So number 4, the limit as x approaches 2 from the right is 5. Alright, number 6, now we have -2 from the left. -2 from the left. I'll go back to green. Actually, yeah, well, that'll be fine. Here's a quick thing. If you see that at -2 there's a point there that's just a value on the graph, then that point, and it's on the line, from the left and the right will be the same y value. So it doesn't matter if you go from the left or from the right, you're going to get a y value for that one of 1. Okay? Alright, I have 2 more questions, and then we'll call it a day. Is the graph continuous at -2 for x? Well, sure enough, at -2, if you just draw through this point, there's no break in the graph. There's a dot there, but it's filled in. So that means that it is continuous. Is it continuous at 2? Well, let's look at what's happening again at 2 here. If I'm drawing my line, let's say I just start here. When I hit 2, am I able to connect to the other line? No. There's a whole gap here, and then it starts up again right here. That means that it is not continuous at 2. No. Okay, so that's it. So basically, this is just breaking down what we did yesterday into smaller pieces. We sometimes will work only with one side of the limit, from the right or from the left. So even if you don't have a limit at the number, you could have a left and right limit at that number. And then continuity means that it flows perfectly. There's no breaks in the graph, there's no jumps, there's no holes. Okay? Alright, so that is continuity. The last thing we're going to be doing is we're going to just do stuff algebraically, which is either factoring or just putting numbers in. So that'll be the last video. I will see you guys later.